Hello dear students. Today we will be looking at lecture number 4, which includes classification of different instruments. So different instruments are classified into analog and digital instruments, mechanical, electrical and electronic instruments, deflection and null output instruments, absolute and secondary instruments. So these are the general classifications that we have. So we'll see each one in detail. Now in analog instrument, the signal vary in a continuous fashion and it can take infinite number of values in a given range. Ammeter, voltmeter, you have a fuel gauge, wristwatch, speedometer, etc. are examples of analog instruments. Here I have shown a thermometer which is analog in nature. But in case of digital instruments, signal vary in discrete steps and they will be taking only finite number of values in the given range. Okay, they are considered to be highly accurate and have high speed of operation, and they generally eliminate human operational errors like parallax errors, and they sometimes are used to store data for future purposes. Digital multimeter is an example. So here you can see that this particular digital thermometer is indicating a reading 98.6. Okay, and what will be the next step of the reading? It will be showing 98.7. But in case of analog meters, it will be continuously showing all the values. But in a digital meter, you can move from one point to another point in small steps only, or discrete steps only. Okay, but they are considered to be very fast and accurate. Now, mechanical instruments are generally reliable for stable and static conditions. They are used to respond rapidly to different dynamic and transient conditions also. Some of the instruments are rigid, heavy and bulky and have large mass, and some instruments cause noise pollution also during their operation. And this is an example for mechanical instrument, which is a fuel gauge. This is an analog type of instrument which has different readings or divisions here. So it will be moving continuously along these readings. So this is an example for analog type of instrument also. Now electrical instruments generally operate using pointer deflection, or it can be digital instruments also. Okay, in most of the cases you'll have a pointer which will be deflecting, and the pointer will be deflecting based on some effect of the current, and the response of this particular electrical instrument is generally faster when compared to mechanical type of instruments. And you have electronic instruments which uses semiconductor devices, and most of the scientific and industrial applications require very fast responses which make use of electronic type of instruments. One of the main advantage of electronic type of instrument is that you can make use of amplifiers, pre-amplifiers and other amplifiers to amplify very weak signals which can be shown, which in the case of electrical instruments or mechanical instruments is not possible or may not be possible. Now the third type of classification is deflection and null type output instruments. In a deflection type of instruments, you'll have a pointer which deflects due to some physical effect, and this deflection can be seen on the dial based on a pointer. So such type of instruments are used to measure dynamic values of measurements, or which changes rapidly. The permanent magnet moving coil instruments or PMMC instruments or moving iron instruments are examples for deflection type of instruments. In null type instrument, you will have a zero or null situation which indicates the magnitude of the measured quantity. The null condition may depend on some other known conditions. A DC potentiometer is an example for null type instrument, which we have already seen how a potentiometer can be used to calibrate voltmeters. So null condition of potentiometer gives you the operating point of this potentiometer or the reading of the potentiometer. So they are considered to be accurate and highly sensitive when compared to the deflection type of instruments. And the last classification is absolute and secondary instruments. Absolute instruments are the ones which give the magnitude of the measured quantity in terms of physical constants of the instrument. Okay, you have tangent galvanometer, Rayleigh current balance, etc. as examples for this. They are generally considered to be standard and are used in different laboratories. So here you can see the image that is given is your Rayleigh current balance instrument. This is used to measure the current or as a standard for measuring current. So this particular instrument is currently kept at National Museum, Japan. Okay, and more details are available in Wikipedia. You can read if you want to. Now secondary instruments are direct reading instruments. The quantity that is measured can be detected from the deflection of the instrument or the reading of the instrument. It not only reads, it will be indicating some value which can be seen. It also, in certain cases, it also records some value also. These instruments are calibrated against a standard, which generally is a absolute instrument, the standards. Now again, secondary instruments are classified into different types. The first one is based on the various effects of electric current or voltage upon which the operation depends. That is, as we have already seen, in deflection type of instruments, the pointer is deflecting based on some effect which the current or voltage produces. This effect can be magnetic effect, heating effect, chemical effect, electrostatic effect, or electromagnetic induction effect. So if we are making use of magnetic effect for the operation of the meter, such instruments come and fall under secondary instruments, and ammeters, voltmeters, wattmeters, in some integrating meters like energy meters fall under this category. You have instrument called hot wire instrument, which make use of heating effect of current. So once the current passes through the instrument, it heats up the wire and length of the wire increases due to heating. So that gives an indication regarding the current that is flowing. Such instrument is known as hot wire instrument. Then you have DC ampere hour meters, which make use of chemical effect of current. This ampere hour meters is used to determine the ampere hour rating of batteries. Okay, and ampere hour, again the ampere hour rating of battery is depending on the chemical effect of the battery. So that particular chemical effect is being used to find out the ampere hour rating of the battery. So such an instrument is called DC ampere hour meters, which make use of chemical effect. Then you have certain voltmeters, which makes use of electrostatic effect, like high voltage voltmeters. When you're trying to measure high voltages, high voltages, so large value of voltages, you will have electrostatic voltmeters available. And then you have electromagnetic induction effect based meters, which generally fall under wattmeters and energy meter categories. Okay, so these all meters are classified based on the various effects of electric current or voltage upon which their operation is depending on. Again, secondary instruments are classified based on the nature of current that the meter measures. You have direct current instruments or DC instruments like permanent magnet moving coil meters, which measures only DC. Then you have alternating current instruments, which measures only AC type of quantities like power factor meter, frequency meter, etc. Then you can have instruments which measures both direct and alternating current, and the example for this one is moving iron instrument. Okay, so we'll be dealing in detail with the PMMC instrument and moving iron instrument in the coming lectures. And we also have secondary instruments based on their nature of operation. Okay, so these are very important. So the first one is indicating instruments. In indicating instruments, you will be indicating the magnitude of the measured quantity. Okay, so you have a voltmeter which indicates the some value. Okay, so you'll have a pointer which moves over the graduated dial or scale. So that indicates the value of the quantity that is being measured. It can be current, voltage, it can be power factor, anything. Okay, so it is simply indicating the value of current. Once the current is removed, or once the quantity is removed, your pointer will come back to your zero position. So it is simply indicating the value of the measured quantity. Then you have another type of instrument which is known as recording instruments. Okay, so the recording instruments will be recording the circuit conditions at a particular interval of time, or for a particular interval of time. You must have seen ECG machines recording ECG. Okay, so ECG machine is an example for recording type of instruments. You have some other instrument which is known as sunshine recorder, which is used to record the amount of sunshine during the day. Okay, so this is another example for recording type of instruments. Again, another example that you can think of is like a seismograph, which indicates the or which records the seismic waves on a sheet of paper, the magnitude of seismic waves on a sheet of paper. Then you have integrating type of instruments which measures the total quantity up to a particular interval of time. Here in recording instruments, you are recording the values or the measured quantity for some interval of time. Here what happens is that you will be measuring the quantity up to some interval of time from the beginning. From your initial value or from your meter is being installed, you are recording continuously up to this particular moment or particular interval of time. Now energy meters fall under this category. We can see that once your energy meter is installed or your KSCB meter is installed at your premises, it starts reading, and every time it will be adding up to its previous reading, and your reading increases every time. So it is basically integrating the value every time, and it is adding it up, adding the value up, and you will be getting new values every time. Okay, so such type of instruments are known as integrating type instruments. So these are all different classification of instruments. So hope you have understood the different instruments or the classification of different instruments. Thank you.